Yeah, thank you. Thanks, Ajit. Yes, so as rightly articulated, so I have prepared a couple of slides just to set the context, Saji. And then, we will quickly deep dive into code and see the different, error codes. How do we kind of diagnose? We'll actually pick up some real examples and, set context to that. So can I share my screen to start off with, please?
Yeah, go ahead.
Yeah, thank you so much. So basically, we'll talk about troubleshooting in production using Java SDK before. So just to set some context, so that we are clear on what the expectations are, right? So firstly, as you may be knowing, right, Cosmos DB has many APIs. It has what we call the NoSQL right now, which is formerly called the CoSQL API. You have the Mongo API, Cassandra, Gremlin. So this is one of the questions I often get, but this talk is specifically for NoSQL only. And secondly, again, we are focusing on Java SDK v4 for the Azure Cosmos DB for NoSQL. And for folks already knowing, right? So what the v4 does is basically combines an async API and a sync API into one Maven artifact that I'll show in code as well. And technically under the hood, you get all the benefits of the Reactor library with, enhanced performance, API features. And this becomes very important when you're trying to diagnose apps. The reason for showing this is if you are right now using like a sync Java SDK v2 or the sync Java SDK v2, then ideally to leverage all the diagnostics and the associated properties and all the benefits associated to it, you should upgrade to v4. That's one important point. And then in short, what exactly is diagnostics? What are we looking at here, right? Why is it important? So in my day-to-day, let's say work, when I work with different kind of teams in one of our large retail customers, so it could be software engineers developing, or it could be architects looking at patterns, predominantly work with a lot of SRE folks, site reliability engineering folks. So the question they often gets asked is, what exactly is diagnostics? So diagnostics is basically a property in Java SDK v4. We're going to look at that, which basically what this property does, it captures certain vital information when you fire a CRUD request. So it's a single CRUD request fired from our SDK. It's doing a few things which we'll look at. And all of the information across all these layers is captured for you. And very important point to note is not just about the successful 200 status, but it also, in case you have certain retries, transient failures in between, it captures all of this for you as well. So it's very, very helpful. So what it basically does is it captures all of this in a massive string, basically returned to you in form of a JSON object. And we'll see that basically, in our demo, we capture it, we kind of little bit, translate it, format it, and then, you get all the information out of it. So as a developer and architect, you need to ensure that the correct SDK you're using, because with the different version changes, the attributes to this JSON artifact also changes. So again, recommendation here is to use the latest one. And, and then of course you combine this with your diagnosis. You either work with Microsoft or yourself, and you can then troubleshoot loads of, like, predominantly 90% of your client side troubleshooting can be done very effectively if you have in-depth knowledge of this, troubleshooting via Java SDK. And one last slide I wanted to kind of cover before we deep dive, because this will become very contextual the moment we open up a JSON object. You're going to see a lot of attributes. The core area to focus on is this particular segment, which we call the transport layer event. So what exactly is this? So the moment you fire a CRUD request, let's say I do a point read or I do a create operation using Java SDK v4. So that specific request actually traverses through certain specific networking layers of our RNTBD stack. That's our TCP engineered stack for Cosmos DB. So those events are referred to as the transport layer events or the TCP events. And these individually, are captured. The latency, the execution is captured. And this is very important knowledge for a software engineer or SRE, because created, queued, acquisition, started, and pipeline happen where exactly on the client side. So if you see high latency numbers for a certain partition or a set of physical partitions, because again, you have an RNTBD address for each of these, you can dig deep into and see, are there anything missing out, or anything, in terms of best practices missed out, or some patterns that were supposed to work is not working correctly for you. Transit time is very important, because that's work done specific on the server. That means I have understood the request, it's gone through the entire networking layers, it hits the replica, it finds the exact physical partition on which it's supposed to do something. Let's say I'm doing a create operation, it did the work, came back, and then eventually, I get the data back. That is the only particular event which happens on the server. Again, once the payload comes back, I deserialize it from JSON into a POJO object, give it back to my client, decode, receive, complete. It happens on the client. This is very, very, very important information for a software engineer or an architect or an enterprise architect, because this kind of gives you where exactly what work happens. And if you see a pattern of latency or errors or exception handling at a particular given layer, you can deep dive into it. And this is, something which is very important. So before we move on to code, wanted to check if you have any, associated questions on these 3 slides that we quickly covered.
Yeah, I have a couple of questions. I think probably basic questions. So whatever you covered so far is specific to Java SDK v4, right? I think, correct. Do we have similar diagnostic output for .NET or other SDKs such as JavaScript?
Yeah, good question. So right now, I did cover the Java SDK v4, but we also have very similar diagnostics on very similar lines for the .NET v3 SDK. But one very important point to note here is if you do execute for the same CRUD, for the same database across the 2 SDKs, because of the difference in stack, the information given by the JSON output would vary. That is something which is very important. But JSONs would be on the Java would be much richer because of Java's inherent capability and all of that. But we do have for .NET as well, and the other SDKs are also will have as time kind of passes.
Got it. The second question is more around the diagnostic property that you mentioned. Can we capture this for all operations, or is it just for query operations?
Good question. So we basically capture diagnostics for 5 kind of operations. Basically, it's 4 plus 1. So 4 means I can do any database operations, I can do container operations, I can do anything specific to an item or a document operations, and definitely all query operations. Plus, for also Cosmos exceptions, which you can capture via Cosmos exception object. That also lets you also define all of these status codes, and for fundamentals, you can do diagnosis. So you can do for database, collection, item, query, and for error as well, having exceptions. All 5 you have diagnostics objects.
Got it. Thanks. I think we can proceed.
Yeah, so then let me quickly jump into code. I will stop sharing my screen. I will open up Eclipse and share my screen. Hang on. So can you see my Eclipse right now? Yeah, so Eclipse would be this screen itself. Is my Eclipse visible?
Yeah.
Correct?
It's in the stream,
yeah. So basically, we have a program here in Eclipse, in Java. One very important point to note here is you have to ensure that you import.
Can you try sharing it again, because we are seeing the screen?
Oh, okay. Hang on. It did not get shared. Sorry. I will share it back. So window is, the Eclipse screen. Can you see right now?
Yep.
Visible, right? Yes, I can see it as well. I think I need to increase the font.
That's right. Yeah. Now it looks good.
Yeah. So basically, it's a program in Java, and we're using the SDK v4. And very important is before you go, always ensure that you're using the latest Maven jar. So for example, here we are using the 4.5, 4.0. This is in fact the latest release. So we have a change log, right? It's a good practice to always ensure and keep the project updated. So here, for example, in this program, right, we are basically creating a database, a container, an item, and iterating through it. You have to ensure that you import Cosmos Diagnostics. So this is nothing but the Java class, basically, which captures the response, stats to a particular object. Now, after that, you basically do the general initializations and all of that. And as you see, right, database, container, item, query responses I can capture. So for example, here I'm doing specifically for the database, for the container. If I go down specifically to the object, for particular, let's say, create item, I'm creating an item here. So here, for example, you see Cosmos Diagnostics class, I define the object. And in the item response object, there are certain methods. So if I kind of delete this and do a dot, you'll see you get around 10, around 11 methods. You can get diagnostics, activity, class, you get the status code, for as a response to that particular query execution, and that particular object kind of captures all the information associated to it. So here basically you need to use the get diagnostics method, which kind of captures and then stores it, and then basically it is given to you as a JSON string. Now let's say I execute this, so you will see outputs like this. This is basic std outs, not very good from the user UI perspective. But here, for example, if you run through it, or you read through it, you will find the different, for example, data here. For example, Cosmos create database, I can see. So this line item is the create database diagnostics. If I scroll down slower, here you have the create container diagnostics. Then you have the create item diagnostics. So what ideally you should do is, when you have generated like this, the best practice is just do a right click and a copy. And then now I will stop sharing my screen because I need to go to the other monitor, which is a bigger monitor, and it will enable you to see. Hang on. So can I right now share this window? Is this visible right now? Correct. So all you need to do is just open up Google and type in JSON formatter. So now a load of them, loads up. There's nothing specific. So I personally like using this JSON, the formatter.validator. All you need to do is basically open up. You kind of copy paste that entire load that you had and ensure that you strip off this info create item diagnostics and just click on, execute. So it basically gives you the entire output. And if I kind of make it a full screen and also increase the size so that it appears on your screen. So this is kind of something as a formatted JSON that we captured from executing that program. Now it's a huge payload, as you see. Now, very important point again, we will just capture or understand some of the high level, but very associated to all of this is captured in one of our blog posts, diagnosing and troubleshooting for common client-side issues. This was published in December end, actually. It also explains you 4 different common use cases that you can leverage, right? And also goes through some of the explanations of some of the, let's call it attributes of this JSON payload. So not going through line by line, but at a very high level, if you understand, the user agent is nothing but you can customize it to the client machine. For example, it says I'm using 4.54. This is very important if you're capturing. I'm running on a Windows machine, the GRE version. Very, very important is if you have a very low latency application and for a specific set of queries, you want to see the entire execution time. So this is the request latency in milliseconds. Very important, milliseconds this is. Request time and end time is nothing but n minus start time basically gives you these operations. So 5.50 and 47, you say exactly it's 3000 milliseconds. So this 2 numbers, minus basically give you this 2697. Response statistics diagnostics, very, very important because this is the bulk. In this bulk of the data, the store result, all of this information practically gives you entire status flow of how that request went. So this store physical address, again, very important for troubleshooting. Why? Because this entire URL is basically a FQDN, a fully classified domain name for our NTBD. That's our software engineered stack. If you see this, I'm going to the prod West US region. I'm connecting to a certain app. I'm giving a particular service. So you are basically going via the service. I have the partition ID to which I went, and even to the replica I hit for executing for create. And as you see, it's a create. So I hit the P, which at the end basically means I hit the primary replica. If this is S, it basically means I hit one of the secondary replicas. So we have a quorum of 4 replicas in a region, right? LSN, very important. That's the log sequence number. So for every operation, you have a corresponding LSN, which is used for different operations, depending on the type of operation you're doing. And this LSN, global LSN becomes very important if you have a session consistency. It's one of the consistencies we have. So basically, the session token is a format. So this 0 basically means, if I go above, it identifies or takes this number. What is this partition key range ID? Is the identifier for the physical partition to which this particular create request went. Now here it's 0 because I have a very small amount of data on the actual container. But let's say in production applications for one of the large retailers, we often have containers with 4,000 physical partitions. So for a precise create operation for one of the, let's say 2,982, if the value comes, you know that this particular partition key range ID you're correctly looking at. And this plays a very vital also role if you just kind of take this and extrapolate and think from an SRE perspective, that which we often do in case of big events, is let's say I have a subset of queries which on all other partitions is working fine, but can I segregate and see maybe that particular set of operations only is having very high latency for one of the transport layer events for a given set of partition key range IDs. That information we can, for example, get here and maybe deep dive and look at, is there anything wrong with those set of physical partitions or the nodes or the cluster on which it lies, or maybe on the replica on which it lies. So it helps you to segregate a lot of these things. So the session token, actually, if you're using, is the value of the partition key range ID minus 1. Basically means that I have a one single write region. So what is my write region here? For example, if I kind of go down here, you will see the regions contacted is West US. So that's the single region write. That means, so this value will change if you have a multi-region setup, multi-write region for a multi-region setup. And 10345 is exactly, if you see, is the LSN value. So this is how the session token for this particular varies, so based on a single region, multi-region with a single write region, and multi-region write with a write deployment, the session token, if you are using, value will change. So these information can be, understood from here. And very important, as I mentioned, the transport request timeline. This is where the bulk of our conversations with team members often happen. So even create just a very high level so that we don't spend much time. We'll quickly go into troubleshooting some examples. Created means basically the SDK has appended some headers, cleared some information, understood the partition logic from logical to physical if it's just the translation. So that took around 1 millisecond. Queued means I've just put the query on a queue, still not sent it. Channel acquisition started, very, very important. As you see here, there's a little bit of cold start. So there are multiple ways in Java you can optimize and bring it down to 1-2 milliseconds, so as to get it warm started, right? So here, basically, I'm getting a channel. What is a channel in Cosmos DB? It's nothing but you can think of a TCP socket connection. So I have a multiple, layer on which I have a tube, and basically I'm querying a socket connection. And now on that, basically I've identified the channel on which I need to queue this. Pipeline means I've now put that particular request in a channel, still not sent it. See, it's took some time as well because of the channel acquisition itself. And then transit time is the most important. That means I have now got to the queue. It's a pipeline multi-tenant system. I have sent across the queue. It has created an object in the database in the correct replica at that FQDN which was given, and then it has come back to me. And decode, replied and completed are just 3 cleanup operations, and then basically I decode and transfer it. I strip off all the extra headers. Receive is some basic cleanup operations, and I completed and given it back to the user. So as you see, these are negligible numbers. So any number which is particularly latency, not sufficing to SLA, you can deep dive into all of this. And then comes errors, which are very important, and I'll quickly show. So here what I'll do is I'll kind of share this screen, but I'll give you some real examples. So let's say I uploaded a particular JSON object, and I will execute this. So let's say we will process this, and I have a particular error which we are getting for a set of operations. So this was executed. This is a real customer example, 4.40. We had certain LSN captured and all of that, but we see there's a repeated set of queries. We have a 429. And there is a substatus code of 3200. Now this is very important for us to know that when you fire, there's a particular status code associated to the requests, but you also have a substatus code. Mandatorily, it's not that every status code has a substatus code. For some, it could be star, which means all, but for many, you have a status and a substatus code for a particular query. So for example, let's say you're sitting down with the team to understand what is happening here, what is going wrong here. So for example, when we scroll down after capturing this, and the question from the app team was like, I see a lot of retries happening for a set of queries. I'm not able to understand, is it specifically owing to some operation we are doing, or is it on the server end? If so, how many retries are we doing? So for example, in the retry context, if you see, there's a 429, 3200, 429, 3200, 4 times. That means there were 4 retries, failure, failure, failure. And on the 4th retry, it was successful and it went through. So technically, there were 4 retries and was a total of 1347 latency. So this is very important now quickly to relate or transfer this. Now you have this information in your hand. What do you do with it? So if you go to the particular blog post, which I was kind of covering, so there are basically 2 things you can do here. So if, for example, let's say, which is covered here. So if I know, let's say I have a 429. Now, all of these status codes also have a sub-status code associated to it. Now, we have a list which I'll show you, which you should refer to. For example, RU budget exceeded means I'm consuming at a given instant of time more than the RUs which have been allocated. They're already consumed. Hence, I'm giving a retry for that set of operation. But how do I get to know from the substatus code? On the other hand, I can also have a 429. But on that 429, I don't get a 3200. That is the third example, for example, I have kind of processed. This is also from one of our customer examples. Here, there is no issue in understanding that there is a 429. But then is it because of RU budget consumed? The answer is no, because you're getting a substatus 3084. So what exactly is 3084 if you go back to here? 3084 is, that means I'm executing a stored proc. So we went back to the app team and asked, are you executing stored proc? The answer was yes. But then millions of them, they must be executing, right? They're not batching it. Hence, you have hit the concurrency limit on that particular instant, right? So that answer is 3084. So this is precisely diagnosing high latency reads. And then, of course, you can take this down. And what Microsoft's recommendation here would be that there is a list where we have captured the commonly found HTTP status code for Azure Cosmos DB. This is a referenceable public documentation, which when we are working with app teams, when we are working with developer teams, we heavily request folks to come back here. And possibly for many of these, you will get to understand what are the different issues you're facing. Now, this document, as we go along, is enriched by an engineering team, by a product engineering team. For example, previously, last couple of years, there did not used to be a substatus code. So request came up, can we get some substatus code for server-side issues? As you see, Microsoft has added a table as well for some common subset of substatus codes. And same thing for substatus code for end-user issues, very important. I'm missing out on the key vault policy, for example. Key is not found. I'm unable to wrap the key. So these are some common, substatus codes as well as, which you can refer to. So, I definitely want to share this and, something which definitely, if you're a developer looking at it or an architect or an SRE, should be, kind of be aware of. Now, what more can you do from this is basically there is another document which is kind of maintained by our product engineering team as part of a GitHub, which basically has a more finer details on different substatus codes. So this is something which we have commonly seen. 410, very, very important. So 410 is not covered here. If you see 408, 409, we directly go to 412 because 410 is an edge case, you may say, but happens if you have very high volume of operations. So if you have this info, so 410 means basically I have a transient error condition where I'm trying to link to this particular RNTBD replica basically to execute, but it for some reason has moved, or I'm not able to get it, or the node exists, the partitions are split or they have merged, but the process is still in transient stage. It is not completed. You will then get a 4110 with a substatus code. So these are different, good information to have on your hands if you are diagnosing. So I will stop here, Saji, if you have any questions, and then we can, go ahead.
Sure. There are a few questions on the chat from the audience. The first one is, I'm just highlighting it as well. So what is the difference between Get Diagnostics on the SDK versus Diagnostics setting on portal?
Yeah, that is a good question, actually. So when you are doing this Get Diagnostics on the SDK, it's basically from the code, the entire life cycle of a request that you are capturing, and you get this in form of a JSON output, and then you can parse through it. So it's a pure dev-centric approach to deep troubleshooting. The diagnostic setting on the portal basically means that you're capturing data plane that are a set of things you can capture, and a set of things on the control plane that you can capture. But for that, you also need to enable log analytics to capture all of that and then push it into a storage for further parsing. So there's a little bit of difference. And the core difference comes up is if you have a situation where you're doing a pattern analysis. Let's say I'm just capturing a diagnostic setting from the portal, pushing it to log analytics, and then I have, let's say, Splunk as a parser to read through it, giving me patterns over a period of time. Because there is a 5-minute delay there, if you're doing a historic study, it really doesn't matter much, right? But then cost is involved. You have to keep this in mind, because once you push it to an external source, those costs associated will add up. But if I quickly flip it on the other side, if you are an SRE team member, you're an app developer who is in between a real-time event, holiday season event is going on, Black Friday, Cyber Monday event is going on, you have 10 million queries which has hit your, let's say, replica, which is very common, got split into, let's say, 2 write regions. For in that one particular region, 5 million, you see 100,000 crossing a barrier of 10 milliseconds. Let's say this use case. You want to deep dive, is it on the client side? Is it on the server side? Is my queuing gone wrong? Or is it something I can quickly optimize? This kind of a real-time situation, which is much lower than 5 minutes barrier, you must do it on the SDK side. That's why this get diagnostics called on the SDK. It's real-time information on your hands. So a couple of operational changes or differences exist.
The second question is more around the diagnostic property that you showed. When Cosmos DB connects to a secondary replica, as mentioned, why the replica status shown as unknown?
So this is, I think, for the first one. Hang on. I think he's referring to this one. Replica status. So basically, this is, you can neglect this. It is not that the replica status is not known. This is a recent attribute which has been added to one of our SDK versions. But it is not that it is not known. It is related to something which is, still kind of getting attributed or getting filled in the SDK side. But it is not that the status is not known. It basically populates if you have a multiple replica statuses, which comes up here. But if you see, right, this particular, hang on, I'll open it up. This particular replica. So this particular replica ID, this is the partition, and this particular replica ID status is 100% known and it's working. That's why you got that particular, let's say, create operation. This is something else. Right now it has got populated, but this is definitely known. That's for sure. And 14304, 103. This is different. Yeah, this is different. Good question, but I'll take a look at that. But this is not in terms of the status, or it's not working, or it's not in working condition. It's not like that.
Yeah, there is a follow-up question as well. Also, if there is a lot of time taken in transition, is it network delay between Cosmos DB?
So if you decode this, it's a good question. So let's say if I decode this here, for example, as I mentioned, and that's why that status operations or where exactly it happens becomes important. So this happens on client, this happens on client. Now this is not network, I cannot say. Why? Because this channel acquisition means I still have, so this is my biggest number. It means I am still to acquire the channel. This is very, very important. That means I have a situation where I have a cold start, basically. So I have to solve this cold start. There are multiple ways you can warm up a cache. You can put it on a particular socket, which is you can keep it alive. I will, actually show some examples there also. Pipeline still means it has not gone through. But if you see this bit is very low, if it ever happens that this is, hang on, if this is around 1, this is 0, this is 2 milliseconds, this is 1 millisecond, but your transient time is massive. That is the only time when you should kind of deep dive into that, whether networking layers are adding any buffer to it. But as you see, right, this is pretty low in terms of the other two. So this for example, I would say it's a cold start problem. That is initialization problem. So you have a couple of steps to do initialization, but this is not a networking delay. So transition time, if you say, if I go back to the question, is it network delay? No, it is not. Very precisely answer, it is not. This is mostly a delay in the cold start. And this is the 214 is yes, it's basically going through the entire network, doing the operation and coming back. And this is, we can definitely do to 2 milliseconds, 3 milliseconds based on the type of operation you're doing. And also I'm using, I believe, and I also believe in my code, I'm using the correct. So there is also a reason, if I show it on the screen, that particular, hang on, is my screen visible? No, right? Hang on, sorry. Oh yeah, so I need to quickly share the correct screen once again. Yeah, so hang on, I will quickly show. So this one, so if you see also in my code actually, so this is a sync object that I'm creating, right? Though I'm using the direct mode, so possibly we would need to create a sync object for this and using direct mode. So that will also definitely improve, but this also definitely makes a big improvement, right? Because in gateway, you're basically using an additional hop. In direct mode, it's a double, multiplexing call. So that amount of time will also be definitely decreased. Yes, please. I'll share back to that screen.
Yeah, I think we can proceed if you have further info to share.
Yes, please. So I have more actually some points. Hang on. So let the screen be shared. Can you see my screen right now? Correct. So there is a couple of common use cases which we have documented. This is very important. So one is any type of high latency, like we shared, you should definitely look at retries and then match that information with status and substatus codes. It should solve many of your problems. For not, you should definitely reach us, and we can help you in the troubleshooting. Very important is there are often times when you have high latency, but you will find high CPU load. This is very different from the first one, where basically it is a lot of high latency reads, 4-point reads. But this can apply for both point reads and also for in partition queries. And what do you mean by high CPU load? How do I see that? So in the JSON, if you go to, there is a serialization diagnostics list, and just below that there is a CPU load. So this CPU load is very important. Basically, it represents the load of the CPU on your client machine. And what we give is basically we do a 5 seconds, push of a 30-second window. This is very important because if I go to this particular document and see it in real time, so it was captured, let's say serialization, you can see that it's 11. And if I see, for example, system CPU load, it's pretty low at 8.2 on an 8-core machine. But it's usually core which is captured as a 5 second window for a 30-second window. If it comes to 95, 99, 99, pretty high, anything consistently up above 70. And if you have a very high serialization value here, for example, mine was 11, still higher than this, right? You should definitely go and look at 2 different things associated with this error. One of our common observations has been the document size is definitely larger. It's not than one of your 5 KB. If you are using something like a 50 KB, 100 KB, even 500 KB we have come across, you will eventually see a set of queries go through, then a bunch of queries having very high latency. You will find very bad numbers in the serialization. So what the SDK does is basically it takes a POJO object, it serializes, because I can't send a POJO, right? I have to send as a byte stream. So converts it into a byte stream, send it across the wire. When it comes back, so automatically also one very important, I'm correlating this, not only your serialization time will be high, but also when you do the decode time will be out of the roof. So you will see very high numbers in decode time, in the transit, it's fine. And also very high serialization numbers, right? And, system CPU load going through the roof. So you should then eventually always, work with the team, do a correct data modeling practice, work with us, and, decrease the document size. This is something very common we have seen, which is on the client side, you can definitely do. And also document depth matters, very important. This often comes up in our conversations with developers, that is it just the size, it's also how deeply the nested the components are. Because please remember, the deeper your document is, you're basically burning CPU cycles during the serialization or deserialization, which will also again send the CPU load through the roof. So this is something which definitely can be optimized by the application code side. Third comes very important, that I have done the first point, I've done the second point, I've very optimized sizes, I don't have layers of depth, but that point reads which are exhibiting very high latency in a high volume sudden burst scenario. This is very applicable if you're in e-commerce. So I don't have a sales volume high, but then the peak comes. In that peak, a bulk of point reads go through. Now, because I'm using a point read, it's supposed to be faster, fastest, right? I'm not even using an in partition. So I precisely have the ID and the document and the partition key. I'm passing it through the read async API. So I really know what I'm doing. But then still I'm seeing very high volume in sudden burst, a little bit of high latency. Specifically, if my mediums, that is basically I have a 100 to a large 1,000 physical partitions in the container range. That means my data size is pretty big. 5 terabytes, 10 terabytes. We work with customers, 50 terabytes, 60 terabytes, but you need that amount of data. Let's say all of that is OLTP data. Then what should you do? So you should then definitely pass through all of this. There is a con CFG value under the client configs. This is very important, and this is really helps solve some very complex problems in some of our large volume retail customers. So this RNTBD value are certain networking parameter values, which defines the basically set certain networking parameters for our RNTBD stack. So in the blog post, if you see the connection timeout, the NRTO value, the idle connection timeout, the endpoint timeout, all of these are defined, and the max channels you can define. All of these values are customizable via the SDK. Now, what we have done is, again, by default, it comes with a 5 second, 0 second, and a 1 hour definition. For bulk of your use cases, you do not need to customize. It will suffice. But going back again to the blog post, if it does happen that you have a very high volume, so we have tested and come out with these precise numbers. That is, if I have a read-heavy app, but which is primarily doing point read, but my underlying container has around 100 to 500 or 1,000 physical partition, then I should be able to time out the connection of the RNTBD stack within 600 milliseconds because I want to flip to another. Correct? So it could be even optimized to 500 milliseconds. Read app, but I'm doing in partition query. Again, you should optimize, not keep it at 5 seconds, but 600 milliseconds. If I'm doing a lot of stored procs, from 5, you should go down to 1 second. If I'm doing a write-heavy app, 600 milliseconds. And if I'm doing an app cross-partition query and cross-regional call, you should have 5 seconds and 1 millisecond. So if you tweak these numbers, you will see much improved latency values across the entire transit time. And again, very important, these will impact which parts of your, let's say, RNTBD transport layer events, not the created, not the queued, not the channel acquisition started, because there are certain specific other optimizations for this, but it will massively help you during the transit time only. And of course, because of faster transit time, your decode executed completed will be much faster. So this will massively improve your latency in milliseconds. So this is something which you should kind of, also be aware of. And certain more explanations are given, like, for example, MCP, that's max channels per endpoint. So that basically defines how many socket connections I wish to configure per endpoint. So it's basically a pipe to the replica, right? So it's by default 130, but I can override it with a lower, higher number or to a lower number. And max requests per channel. So these again come with certain default values, as you see right here. So you can customize these as well. So MRPC is 30. You can also customize it and push more, requests per channel, the socket connection to send through. And then there is one example, which I'll quickly cover and, we'll take questions, is if you have an in-partition queries with a very high latency of, high volume sudden burst, you should then definitely, optimize it to certain values. And how do you do that in code? Basically in Java, when you are configuring, you customize, the initialization section and basically pass certain values in set network time, request, idle connection, idle endpoint timeout, max connection, and then you basically initialize the client. So please remember, the SDK always overrides the one which you have. So these values will be used. So this is, what I wanted to cover. And of course, associated to all of this is this particular document. So let's say And I wanted to quickly cover this also, Saji. For example, you can open up Stack Overflow. So there is one question here. For example, somebody has told, right, I'm using system under load, I'm having 7 to 9K, which are randomly getting. And exactly these are the kind of cases you will walk into, right, when you're working with an app team. That I'm executing this, working perfect, but upon some volume of requests, I'm getting randomly service timeout. So see, this person has pasted, not the full, but a little bit of, let's say, the JSON output. So the moment I saw, I looked at 4110 gone exception true. So 4110 means a couple of things. So if you were, let's say you had this knowledge and you're sitting down to execute. So all you would basically need to do is go to 4110. And as you see, it did not have any precise substatus code. So let's say it was a substatus code 21007. It basically means read quorum not met, because it could be achieved using strong or bounded staleness. They're reading it faster than the quorum has been set. Again, this is a transient. So your simple answer to this by looking at it should be, why don't you retry that set of queries? That 410 should disappear. And then see, this error should always be mapped to a Cosmos exception. So if you're trying to capture it to the app code, it will be 503 when servicing it to the application after exceeding SDK retries. So this is a live example. You can open up anything, any error, and can quickly do an analysis yourself. For further deep dive, of course, we are there always. So that kind of covers it. Yes, Saji, back to you.
Thanks, Subhashish. I think it was a great session with all the samples and also scenarios that you explained. Audience, if you have any questions, please post them in the chat. I have a couple of questions.
Yes, please.
You mentioned about enabling the diagnostic, right? And is there a way to auto log these diagnostics output for query operations? Cosmos. Mainly as a developer.
Yeah, and there is. In fact, it was not. It was non-existent earlier, you may say. But this. So there's one particular page which has been created, right? Troubleshooting. I will share this. I will kind of delete this and paste this. So this is basically troubleshooting Java, right? And you can select the particular version you are on. So here it gives you some examples, but then this section has been added. So what if I want to log it? Now, very, very important, auto logging is enabled right now from version 4.43.0 onwards. And how do I know this? So basically we have a change log history, we call it, right? So it's ideally one of the documents. So basically you can go and take a look at the change log history where we have all those logs. So 4.43 onwards, basically you can define a threshold. So I can define a threshold for latency, or like for point or non-point operations. Point means I'm doing a create, read, certain set of CRUDs, non-point operation. And then I can define my custom diagnostics handler. And I can then capture those, auto log it, and then push it maybe to a further downstream to kind of analyze it. So right now it's 100% possible, but please remember from version 4.43.0 in Java onwards.
That's a cool feature. I think I have seen customers requesting it, but they don't have to enable this always, right, based on the settings they configure.
Absolutely.
Thanks for sharing.
Yeah, Saji, and also one very important question from an SRE perspective, looking at it, the recommendation of Microsoft is also that you do not capture. Actually, I missed out this point, very important to cover, is should I capture this information all the time? Is a very common question we get. The answer is no, because the payload increases. It's a massive size as you see the JSON. So should I capture it if I'm doing 100,000 operations at a given instant, let's say, for my production? No. You should only try and understand those subset of query operations or database operations or exception operations. Only activate it as a custom logging, capture a subset of those, then sit down for diagnostics, because diagnostics data will not immediately change, right? It's version to version. And then you deep dive and segregate those subset of queries. That is an important point.
Yeah, those are the questions I had, and I also see that you have already shared the status code documentation with us.
Yes, please. So,
share with the audience.
Yes.
Thanks for your time. I think it was a great session, Subhashish, and it's been wonderful that you were going through step by step and sharing the information that all the developers and also customers would need. Do you have anything else to share with the audience? So, can we wrap
No,
up?
I think we have covered practically everything, from initialization to understanding to, of course, it takes some time to translate that info. But if you do have these reference documents, the public one and the GitHub ones, you should be pretty much, well covered to kind of do a lot of diagnostics yourself. But thank you.
Yeah. Thanks again. Thanks for joining. Thanks for joining, audience, and those who asked all these questions. We will catch up again in 2 weeks to talk about one of the recent advancement feature that we added in the Mongo code. We'll catch you again in a couple of weeks. Thanks again.